In this lesson, we'll learn about summations. So basically what a summation is, it's when we take and we add up the individual terms of a sequence. So this is where we kind of shift gears from talking about sequences, which is just a list of numbers separated by commas, to a series where now we're actually going to be adding the terms. So it means instead of having all of the terms separated by commas, they're going to be separated by addition. So we're going to be adding up a specific number of terms. There's something called a finite series versus an infinite series. Finite means there is a specific number of terms that you can add up, versus infinite series means that it's going to keep going. So it's going to be an addition with a dot, dot, dot at the end, meaning you could keep adding things to it. So what a summation does is it provides a notation that allows us to represent a series. So when you see this notation, we have this big symbol here, which is called sigma. And there's some important things here. So the function is really the rule. So it's the rule that defines the sequence, or it's the rule that defines the numbers that you have that you then add together. The value at the bottom here is called the lower limit. This is where you start. So this is your first n value that you would plug in to generate the first term of the series. And then the ending number is what makes it finite. So it tells you, okay, this is the number, this is the last number for n that you're going to plug in. So if you look at this example, let me go to one that's already worked out, then I'll go and do number one with you. If I look at this, so we have this summation here. The 3 out in front just means 3 times this summation. So the starting number here is n equals 2. So that means I'm going to use this rule to get each term in this series. So I'm going to take and I'm going to plug 2 in, and then I'm going to plug in 3, then I'm going to plug in 4, then 5, then 6, and then 7 is the last one that I plug in. It will always be that you plug in consecutive numbers. So if you start at 2, that means you're going to plug in 2, 3, 4, 5, 6 until you get to whatever the number is that you end with. You basically reuse this function or this rule. You're going to reuse that for each number that you're plugging in. And then from there, well, now you can just evaluate it. You just simplify it, and now you're getting a sum. So basically, what this sigma is doing is it's adding up all of the terms that you get when you plug in 2 to 7, all of the consecutive integers that you plug in from 2 to 7 is what's happening. And then it'll multiply at the end by 3, or you could think about it as multiplying each term by 3. It doesn't really matter. There are some calculator steps, so there is a way to do this in the calculator. You need to be able to do this by hand, so I'd recommend doing these problems by hand to start. And then you could use the calculator. There's the button in the calculator that looks like this. You can press that. You'll find the sigma right there, and then you just plug in. That's as easy as it is. There is a way to list out the sequence. I wouldn't worry so much about this, but it's there if you'd like to try it. So let's just try this practice problem together to make sure you have the hang of it. So again, this is my starting. So this is the number that I'm going to plug in first. This is the ending. This is when I stop. So that means I'm going to plug in 1, 2, 3, 4, and then ending at plugging in 5. My rule that I'm going to use every time that I plug in is going to be n squared. That's the rule that defines the terms in this series. So basically it's going to look like, well, start with plugging in 1 for n. Then you're going to plug in 2 for n. Then you're going to plug in 3. It might be sometimes easier too to just rewrite, like, what's the pattern here? Just rewrite it with parentheses where you see an n. That might be helpful, just so that you remember to plug in the numbers. So I plug in 1, then 2, then 3, then 4, then 5 is where I end. So that's exactly what this notation means right here. And now from there, I just go through and simplify. So 1 plus 4 plus 9 plus 16 plus 25. Add all of those up, and you get 55. So that's what a summation is. It's just a way to represent a series or adding up the numbers. And then you'll always get these will always be given to you. So from n equals 1 to 5, that's how you know what terms to add together. And those can be any starting and ending numbers. Another type of problem that you have to do is be able to find the number of terms in this series. So what that means is how many terms are in this series. So you could actually, just kind of go through and count in your head. If you're starting at 1 and you're ending at 7. An easy way to kind of think about this is the number of terms will always be the difference of these two numbers, the lower limit and upper limit, plus 1. So it's the difference of upper and lower limit plus 1. So 7 minus 1 equals 6 plus 1 gives me 7. That means there's 7 terms. And I'll let you finish the other ones. That's all you do. It'll always work if you just use that rule, but really you could always just count. So I'm starting at 1, then I'm going to 2, all the way up to 7. Whatever is easier for you on that. The other type of problem, so you can finish those ones up on the next page. The other type of problem on this page is being able to be given the series and know which is the correct notation. So instead of generating the series, this is asking you to go backwards. So basically come up with the rule. So the easiest way to handle a problem like this is honestly just check the terms. I mean, you could come up with a pattern yourself. So what's happening here? Okay, I'm adding 2 each time and figure out, okay, what's the rule that adds 2 each time? And then from there, you could figure out which values would be correct when I plug in for the lower and upper limits. But a quick way is really just check the first and last terms. So if I plug in the first, so k equals 1, so I plug in 1 for k. Okay, well that means I get 2 minus 1, so I get 1. And then, so that's good because that matches the first term. If I check the last term, well, that would mean plugging in 20, so there'd be all these in between terms. So that gives me 40 minus 1, and that just so happens that it gives me the last term. So this should be the answer, but you really should go through and check the others because what could happen is the first and the last terms might match, but what about the second term? Maybe the second term doesn't match. So if you go through and you check the first and the last terms and the only correct first and last terms is this choice A, well, we know that that's the answer. But if you have 2 with the same first terms and last terms, well then, in that situation, maybe check the second. Usually what'll happen is as long as the first and last terms match, you'll be good to go. Sometimes you might have the same first terms though, so be careful. Make sure you check multiple terms before you make your decision. Okay, so the rest of these is really the same idea. So I'll let you finish up that one, checking it. And I think the other problems are all good. So the only other thing I wanted to point out here was on page 27. Just notice that when I look at number 8, which series is represented by this, here's that whole idea of infinite series. These are all finite series because they have a finite number of terms. They end. So this cannot be an answer because I have a starting point and I have an ending point. So it means it ends. So you can't have a dot, dot, dot. You can't have something that goes on forever. So just be aware of that when you're, looking for the pattern here, or the correct answer to it. So other than that, I think that gives you enough instruction. So go ahead, finish the notes, and then go ahead and do the homework.